All right, good day. Hope that you're doing well. So in this video, we're going to be looking into this analytical geometry exam question, right? So now in the diagram below, we're given the equation of line AD, which is 2y plus x, it is equals to 11. So the first step is for me to write this equation to be in terms of y, right, in standard form. And how would I go about doing that? I'm going to take the x to the other side. So here, I'm going to have 2y is equals to 11 minus x, and I'm going to divide both sides by 2, right? So that my equation could be in terms of y. So if my equation is in terms of y, this would be equals to, so I'm going to put the x fix. So this is the same as negative 1 over 2x plus 11 over 2. All right, this is my equation in standard form. So let me quickly erase here on the sides. Now let us continue with the questions that we given. So, basically analyzing this information, they're also telling me that M is the midpoint, right? M is the midpoint of the straight line joining B and C. The angle of inclination of AD, right? So where exactly is AD? So the angle of inclination of AD and BC are A, right? So they've given us the angle of inclination and B respectively. So A and B, these are angles of inclination, right? And remember, how do we go about calculating our angle of inclination? We're going to make use of that formula whereby we say tan of theta, which is equals to m, the gradient of whatever line our angle of inclination is attached to. Now, EF are y-intercepts, all right, and also A and D. So basically this information, okay, so basically this is what I can get from the information above. Let me see what the questions are requiring from me. So the first question is calculating the coordinates at B. Now, what is it that I'm going to use? I'm going to use point M, which I was told that M is the midpoint, all right? And how did we get the X value of this midpoint? Remember we said X1 plus X2 all divided by 2, we got the X value of our midpoint, which is 1, right? And similarly, to get the Y value of our midpoint, we said Y1 plus Y2 divided by 2, we got negative 1. Now let me substitute into this formula here. So my X1, I'm going to make it C, my Y1, it's also at point C, right? So my X1 is going to be 3 plus my X2, which would be my X at B, right? I'm going to replace that with A over 2. This is equals to 1. So doing the same on the other side, my Y1, my Y at C is 4, plus my Y at B, it's represented with an alphabet B, divided by 2, we're going to get negative 1, right? Now, to get rid of this 2, we need to multiply it on both sides, right? So I'm going to multiply both sides by 2 so that these 2 could cancel out. Similarly, I'm going to do the same this side, multiply both sides by 2. So as a result, here, I'm going to be left with 3a. This is equals to positive 2. On the other side, I'm going to be left, right? So this is basically 3a plus b. So let me just quickly erase here. So 3a, so this is basically 3a, this is equals to 2. Here I'm going to be left with 4 plus b. This is equals to minus 2. Right? And to find A, I'm simply going to take the 3 to the other side. Similarly, to find B, I'm going to take the 4 to the other side. So this would be A. A would be equals to 2 minus 3, which is negative 1. And what about my B? My B is going to be equals to negative 4 minus 6, minus 2 rather. You're going to get minus 6. So my coordinates at B are negative 1 as well as negative 6. Right? So let me erase here so that we could do the other questions as well. Now, moving on to the other question, we are required to determine the gradient of line BC. All right, so let me look at my line BC. So this is, I have the coordinates at B, I have the coordinates at C. BC is also in the same line as CM. I could use the coordinates C and M, but in this case, let me just use the coordinates of C as well as B, right? So remember your gradient formula, y2 minus y1, it is equals to x2 minus x1, right? So I'm gonna use point C as well as point B, right? So my y at C it's 4 minus my y at B it's minus 6, all divided by my x at C it's 3 minus my x at B, which is negative 1. All right, and now at the top I'm gonna have 4 plus 6. Here I'm gonna have 3 plus 1, and now punching this into my calculator, 10 divided by 4, right? So this would be 10 divided by 4, which is the same as 5 over 2. Right. So the gradient of line BC is going to be equals to 5 over 2. So let me just finish up erasing here so that we could look into the next question. What is it that they want us to solve now? Now, determine the size of theta. Now, what is theta? Here's my angle theta. And how would I go about determining it? I know that these are angles of inclination. So let me start off with finding the angle of inclination B. So if I could find this angle B, if I could find this angle here, right, I can be able to solve for theta. So the first angle that I'm going to try and solve is my angle B, right? I'm going to make use of my angle of inclination formula, tan of B. This will be equal to my gradient. So tan of B, what is the gradient of the line that B is attached to? Remember, B is attached to line BC, right? And we determine the gradient of BC as 5 over 2. So to find B, I'm going to take the tan to the other side. So this is going to be the inverse of tan, 5 over 2. And now punching this into my calculator. So the inverse of tan, 5 over 2. This is going to be 68,2, rounding off to 2 decimal places, right? So 68, or let me just not round off up until I get to my final answer. This is 68,1985. So this angle here, it's 68,1985. Now I need to find this angle. How would I go about doing that? So do you agree that if I could find my angle of inclination here, which is angle A, I can be able to find this angle here, right? Why is that? These are angles on a straight line. And remember, angles on a straight line, they add up to 180, right? So let me go about finding my angle of inclination A, making use of the same formula. Tan of A is going to be equals to M, right? So the tan of A, what is the gradient of that line, AD? So let me see if I'm given. Okay, remember the equation of our line AD, this is the equation in standard form, and negative 1 over 2 would be our gradient, right? So here, this is going to be negative 1 over 2. Now I'm going to take tan to the other side to solve for A. So this would be the inverse of tan, 1 over negative 1 over 2. Right. Now remember, okay, let me just quickly punch this into my calculator. The inverse of tan minus 1 over 2. I'm going to get negative 26. Right. So basically, I'm going to get negative 26,57. Now, remember, every time whenever you find in the angle of inclination for a negative angle, your final answer, you must add it by 180, right? So basically you must add 180 to your final answer, right? So if I add 180, this angle of inclination would be equals to 153, right? So my angle of inclination is 153. And how would I find this angle, right? So 153,43, as mentioned, these are angles on a straight line. To find angle CD, right? Basically this angle here highlighted in red, I would need to take 180 and minus 153,43 because as mentioned, these are angles on a straight line. So 180, I'm going to get 26,5. So this is 26,565. Now, lastly, sum of angles in a triangle, right? So I know that 180 minus 68,1985 minus 26,565. I'm going to get my angle theta. Why is that? Sum of angles in a triangle, they equate to 180. All right. So now let me just quickly punch that into my calculator. Minus 68,1985. This theta here would be equals to 85,24, rounding off to 2 decimal places, right? 85,24, and that will be your final answer, right? So let me quickly erase here so that we could do the other questions as well. Now, we found theta. Now we need to determine the equation of BC, right? So BC, okay, I need to determine the equation of BC. Remember, I found the gradient of BC before, right? So this is a straight line and it must be in the form of y is equals to mx plus c. My gradient is 5 over 2, and I'm going to substitute any point on this line BC. I'm going to substitute point C, right? So my x at C is 3, my y at C is 4. So I'm trying to find my y intercept, right? And as a result, 5 over 2 multiplied to 3, this would be equals to 15 over 2. This is 4 plus C. Now taking the 15 over 2 over to the other side is going to become a negative now. So negative 15 over 2 plus 4, this would be equals to minus 7 over 2, which is our y-intercept. So basically, the equation is y is equals to 5 over 2 x minus 7 over 2. And as mentioned, this would represent our y-intercept, meaning that, can you see the y-intercept of this line? It's at point F. I know that my x value at point F is going to become minus 7 over 2, and the x value is going to be 0 because this is a y-intercept. All right, now with that being said, let me just erase here and let me try to answer the other questions as well. Now, we need to determine the area of triangle CEF. So let me highlight that triangle here, right? Triangle CEF, right? Remember the formula for your area for triangles, 1 over 2 base times height, right? Multiplied by base multiplied by height, right? So what would be my base here? Can I find the coordinates at E, right? Do I have the equation of line AD? Yes, I did. I did calculate the equation of line AD before, right? So it's just that I've erased it here. Remember, this is the equation here. I said we're going to take the x to the other side. So we're going to have 2y is equal to minus x plus 11. And we're going to divide both sides by 2. So basically, y is equals to negative 1 over 2, x plus 11 over 2, right? Now, 11 over 2, it is the y-intercept of this line AD, right? And as a result, I know that my coordinates at E is 0 and 11 over 2, right? Now, remember, I'm trying to solve for my area, right? In this instance, EF is going to be my base. I need to find the length from E to F, right? So I have the y value at E, which is 11 over 2, right? So I have the y value. So I'm going to say 11 over 2 minus what is the y value that I have at point F? At point F, the y value that I have is negative 7 over 2. And I'm going to find the distance between these 2 points, all right? And doing so, 11 over 2 minus negative 7 over 2, this would be equals to 9, right? So the length from E to F, so this is the length from E to F, it's 9. And as mentioned, this would be my base, right? So let me rewrite this on the side. So I have 1 over 2 multiplied by my base, which is 9. Now, my height is must be a perpendicular height, which is something like that, right? Now, I want you to note something. Can you see that this line that I've just drawn in red, it is a horizontal line. And if you could put something like this, for example, let's say the coordinates at this point, it's 2 and 1. And I have point F here. These 2 points, because this line is horizontal, they're going to have the same x value, right? This x value at F is also going to be 2, right? Because they are on the same line, right? They are horizontal. So similarly, right, the distance, right, from this point up until my highest point would be 3, right? As y, because remember 3 it will be my x value here. So my x value at this point would be 3, meaning that the horizontal distance is going to be 3, right? And what exactly is this horizontal distance? This is my perpendicular height. So this multiplied by my height of 3 and punching this into my calculator, this is going to be equals to 13.5 units squared, because this is a area, right? And this would be my final answer for this question. All right. Hopefully that makes sense. Remember, if ever you have any questions, always feel free to reach out. Thanks.